Okay, so chapter 4, section 8 is using isosceles and equilateral triangles. Yes?
Just on Canvas, it said that homework is due tomorrow.
For 4.8?
Yeah.
Okay, I will correct that. For 4.8, actually a lot of you have come up with, so you guys have already told me some of the things that you're about to learn today. Some of you have come up with these ideas on your own. I've just kind of brushed over them because we weren't ready to talk about them yet, and now we are. So we're going to talk about things that are true with isosceles and equilateral triangles. Okay, so when we talk about an isosceles triangle, we have to talk about the parts. So in an isosceles triangle, what is true about every isosceles triangle in the world? How did it get the name isosceles triangle? There are two congruent sides, right? We know that two sides match up. Well, those two sides that match up in an isosceles triangle are called the legs. So the parts that match each other are called the legs in isosceles triangle. The piece that does not match the other two, we call the base. Now, if you notice, in every triangle, because it is a triangle, there are three angles. These two angles, the ones that are touching the base, are called the base angles. The one that is not touching the base is called the vertex angle. So we're going to be talking about base angles and vertex angles. We're going to be talking about legs, the base of them. All you need to know is the two pieces that match each other are called the legs. It is the third piece, the one that doesn't match, is called the base. And the two angles that are on the base are called the base angles. Yes, ma'am?
Okay, could you say, like, where it says base, like, if that was a leg and then one of the legs said base, like, if they were congruent?
I'm confused.
Like, okay, you have two sides that are the same.
Here, those are the legs.
Same, and instead of, like, I don't know, maybe the right leg being the same, could the bottom
If it was, so I think what you're saying is this, and correct me if I'm wrong because I might be misunderstanding. So I think what you're saying is this. You're saying if, I'm going to lose all that and it's not going to show up in the notes if I don't put it back. Okay, so let me just erase it then. I think what you mean is, could it look like this? Yeah?
Yeah. Like,
Let's say I had a triangle that looked like this. Then this would be the leg, this would be the leg, this would be the base.
Right, yeah.
And then these would be the base angles right here. This would be the vertex angle up there.
So it still works that way? Right?
It works no matter which way it's pointing. Just the two congruent sides are called the legs.
Okay.
In an isosceles triangle. Okay, so here's what's really cool that you can get from isosceles triangles. It works every single time, and it's very, very important. But you have to remember that what we are about to do is called the base angles theorem, which means that this may come up in a proof because here's another theorem, because you have not learned enough theorems already. So, base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. Meaning, if you find an isosceles triangle, which this one is, like if they say that if AB is congruent to AC, okay, well AB is congruent to AC, then the base angles, if you want, you can use these like arrows pointing to the angles that we're talking about there. The ones that are touching the base will always, 100% of the time, be congruent to each other. 100% of the time. So it's actually very easy to figure things out in an isosceles triangle because those two angles, the ones touching the base, it has to be the ones touching the base, are always congruent. Base angles theorem. Okay, so now we've got the converse of the base angles theorem. Well, remember every time we hear that converse word, it just means the backward version of that. If two angles of a triangle are congruent, like these two are right here, well then guess what kind of triangle this is? If those two are congruent, it must be an isosceles triangle, and it means that this was the base, so the two legs have to be congruent. It's just the backwards version of exactly what we just did. If two angles of a triangle are congruent, then the sides opposite those angles are congruent, meaning that one will be congruent with that one right there. If angle C is congruent to angle B, then AB is congruent to AC. So far, so good? All right. Okay, corollary to the base angles theorem. Remember, corollary is like the DLC of theorems here that we're just going to add something on. We've got two add-ons here. If a triangle is equilateral, then it's equiangular. Well, we already talked about that. I snuck that in a little bit early because I thought it was very important. So every triangle that is equilateral is also equiangular, and vice versa. Every triangle that is equiangular is also equilateral. The corollary to the converse of the base angles theorem says if a triangle is equiangular, then it's equilateral. Because remember that we learned that an isosceles triangle has at least two congruent sides. Well, that makes this an isosceles triangle. It is an isosceles triangle. More specifically, it's an equilateral triangle. It's a little delayed there, not showing up on the screen. But that triangle is an equilateral triangle, but it's also an isosceles triangle there. So that one, because of that, notice that the base angles are congruent. It doesn't matter which one you use as the legs there. Because all three sides are congruent, all three angles are congruent, it still matches the base angles theorem. Yes, ma'am?
Okay, I'm confused because I thought...
Yes, ma'am?
And what would be the vertex?
So in an equilateral triangle, we don't really have base angles and a vertex angle because it's an equilateral triangle. It's more specific than that. But one thing we know about an equilateral triangle is all the angles are congruent, all the sides are congruent. But that still matches up with an isosceles triangle because we just learned that if these are congruent, then those two angles were congruent. And even if you switch the legs, even if you go, okay, well, let me use a different two legs. Okay, let me use this leg and this leg. Okay, well then this angle and this angle are congruent. It's still true. It's true no matter what you use. Yep.
So anything could be the legs, and anything could be the base.
In an equilateral triangle, yes, because they're all the same anyway. You know all the sides are the same, all the angles are the same. Okie doke. So let's find the value of x in every situation here. What kind of triangle is this? It's isosceles. And what do we know about the isosceles triangles? It has two congruent legs. Okay, here's a congruent leg. Here's a congruent leg. What else do we know? Yes, ma'am.
that the angles are congruent and the legs are touching.
Yeah, so what exactly? So you missed this terminology, but that's okay because you've already got the concept. The base, the one that is not the legs, the base angles will be congruent, meaning that this must be x as well. The base angles are congruent. But they didn't ask me, is that x? They asked me to figure out what x is. But whatever it is, I know it's the same thing. Amber, you got something more? Keep going.
So, can I tell you how to
Please,
do that?
yes.
So you're going to do 2x plus 30 equals 180.
How did you get 2x?
Because there's 1x plus 1x, which is 2x.
Perfect. I just want, just in case somebody said, how did you get 2x? Because we add the x's together, x plus x is 2x. Okay, so now where do we go from here? Okay, so 2x is equal to 150. And then x is equal to? 75. That's 75. That's 75. Because the base angles are congruent in an isosceles triangle. We okay on that one? I don't think this is a terribly hard lesson, but you got to tell me if it's not. Okay, be real careful here. These are referring to the sides, just to be clear. This is x plus 5. This is 2x plus 4. They're talking about the sides here. And this one is 2x plus 2. Colette, you want this one?
So, the two legs are always equal to each other.
Why? How do I know this is an isosceles triangle? Because the base angles are congruent, it must mean that this is an isosceles triangle. So which ones are the legs then?
2x minus 4 and x plus 5.
How did you know those two?
Because those are the base angles of the
Perfect. So the base angles, the two base angles, the two that are congruent, are touching the base. That must mean this is the base, meaning the other two are the legs, meaning these would have to be the congruent parts there, because notice the base angles are the two angles touching the exact same side. That side is the base. All right, keep going, Colette.
So then, instead of your equation, it would be 2x minus 4 is equal to x plus 5.
2x minus 4 is equal to x plus 5.
And then you have to get x on one side, so you subtract x from the right side,
Okay.
and then you get x minus 4.
Oh, sorry. X minus 4 is equal to 5.
So then you add 4 on both sides, and you get x is equal to
What if I asked you about the side length of one of these? What if instead of asking for x, I had asked you for a side length? Where would we go from there?
you have to plug it into whichever side.
Just plug it in. What's going to be true about the side lengths here and here? They're going to be the same. So like, it's a great way to check each other. If you plug it into one and then plug it into the other, and for some reason they're not the same, something is wrong. All right. Let's talk about this one. This one takes a little more thought here. 42 refers to the length of this side. 41 refers to the length of this side. Those two things are not congruent. 56 refers to this angle, 62 to this angle. Those two are not congruent. Talk to me.
So what I looked at, I was trying to see like, wait, hold on. Yeah, so I wanted to try to find the angle.
Okay, I like everything you're saying. Talk to me.
So I added 56 plus 62, and I got, well, I didn't really do this, but I got, yeah. And then I did 180 minus 19, and I got 62. And so that equals 62. So now you know that the 41, that's the base, because the base angles are congruent.
This is definitely the base because we have now seen, just in case you're not sure what she's doing, she noticed this, meaning those must be base angles, meaning this must be the base.
And so to find x, I saw that the 42 and the x, they're the legs, so x equals 42.
Done. But it didn't look like it. They set it up purposely to try to steer you away from saying it was equilateral or it's not equilateral, I'm sorry, isosceles. So it tried to steer you away from it by making everything look different. But the parts that were missing were the parts to prove that it was an isosceles triangle.
Wait, okay, I got everything set up until how'd you get x equals 42?
So she came up with the idea that these base angles right here were congruent, right?
Right.
So what kind of triangle must it be then?
Isosceles?
It must be isosceles. This is the base right here, meaning that these two things have to be the legs. And what's true about the legs? They're congruent to each other, right? So if one's 42, the other has to be 42. Oh, this is kind of nice. This is like place them in the appropriate order. So this is just like if you've done the online ones, it says we just need to put them in the order and provide the reasons. So let's do the statements and the reasons. I think maybe we'll stop after this. Like, 'cause there's still 2 slides after this, and I think that might be a good place to stop is right there. Let's get through this one, and that because the other classes aren't as long, so I need a little more time with them. Let's talk about the appropriate order. This is what they are given to me, and this is what I am trying to prove. So what is the very first thing I'm going to say out of A, B, C, and D? Right, D. Angle 1 is congruent to angle 2 because of given. Let's cross that off. That one's done. What is the last thing, the very last thing I'm going to say? Right, so just remember that that's last. Okay, that's the last thing that we're going to say. So it's either going to be A or B that comes next. The question is, which one of those can we say right now? Yes, ma'am.
A because of the vertical angles down.
So A says that angle 3 and angle 4 are congruent to each other, but those don't look like vertical angles to me.
Oh.
You're right that 3 and 4, maybe they are congruent to each other, but I don't know how yet. B because of vertical angles. So here's 2 and 4 here, and here's 3 and 1 here. We can definitely say that. So let's say angle 2 congruent to angle 4 and angle 3 congruent to angle 1 because of the vertical angles theorem. Well, I mean, this shouldn't take much thought at this point as to what we're going to say next. What are we going to say next? Angle 3 is congruent to angle 4. Now, why though? Yes, ma'am. Colette. Okay, so what is the connection that we're making? So how do we make the connection between, how did we make that connection?
Well, is it a transit or substitution?
Okay. Talk to me about how you saw it. Like, because we need to make the connection between 3 and 4.
It's because we know that angle 2 is congruent to angle 4.
Mm-hmm.
3 is congruent to angle 1. So, and we also know that angle 2 is congruent to angle 1, which makes angle 3 congruent to angle 4.
Okay, let me just reiterate what you said. If you're not seeing it, we are trying to make the connection between angle 3 and angle 4. So check it out. We already know that angle 3 is congruent to angle 1, and angle 1 is congruent to angle 2. So now 3 and 2 match up. 3 and 2 are exactly the same. But also 2 and 4 match up. So 3 to 1, 1 to 2, 2 to 4, then yes, this is the transitive property. That's exactly what that is to make that connection. And then last but not least, we've got OK is congruent to OJ. Yes, sir? The converse, because we already have the angles, converse of the base angles theorem. Oh, sorry, it's taking a while to show up there. There you go. Yes, ma'am?
So does converse apply to everything?
So in most things where, I shouldn't say it's no, it doesn't apply to everything, but there are a lot of things that it does apply to. That if you can do things one way, that it'll work backwards too, but it doesn't apply to everything. Very last proof. So we're going to write this as a proof. Given M is a midpoint of AB, the measure of angle 1 is equal to, that should say the measure of angle 2. Bless you. And we are going to try to prove that AC is congruent to MB. That those two lines are congruent. Should look like that. So let's talk. Yes, sir.
AM is congruent to BM?
AM is congruent. Well, let's write this out as a proof. How about this? Let's go. Or actually, no, I like the way you're doing it. Let's just talk as like normal people first. He said AM is congruent to BM. I like that. Why?
Because of the definition of midpoint.
Okay, because M is the midpoint, and that is the definition of midpoint. M is the midpoint of MB. It's the middle of line AB, which means that it's split perfectly on each side. Okay, what else? What else do we have? I don't know.
Confused when
Angle 2 and angle M are linear pairs,
Hmm?
right?
They could be, but actually we're kind of we are not like looking at some like information we could use right now. Yes, ma'am.
Angle 1 is congruent to angle 2.
How did we know that?
Oh, wait a minute, what? Oh.
The measure of angle 1. It should look like this, by the way. I'm sorry. It should look like this. I apologize for that not being written more properly. It should look like that. Measure of angle 1. That still looks weird. Let me just fix that. The measure of angle 2. Okay, that's what it should look like. So angle 1 and angle 2. Okay.
Then can I do the angle 2 plus angle M equals 180?
You can, but that's actually, ultimately what we're going for is, look at what we're trying to prove. We're trying to prove that AC, this line right here, is congruent to MB, this one right here. So we need some sort of way of connecting this. I'm not sure angles is going to do it, but maybe.
We can do angle AC is congruent, or line AC is congruent to line AM.
Why is AC congruent to AM?
Definition of isosceles triangle.
But they never said this was an isosceles triangle.
But you know, since those two are congruent, the two
Because which two are congruent?
Angle 1 and angle 2 are.
Because angle 1 and angle 2 are congruent, so what? Like you're saying some great things here. I just want you to say it in the proper way. Because they are congruent, then
And the two legs are congruent.
okay, so she's saying because these two angles are congruent, that's what they gave us, then she's saying that these legs must be congruent. Would be our reason for that?
Wait, but how do you know it's not equilateral?
Well, we don't. It may be equilateral.
I mean equiangular.
It may be equiangular too, but even an equiangular one still has all the properties of an isosceles triangle. What do you got?
Oh my god, base angle theorem.
So base angles theorem is not going to help me here because the base angles theorem says if I already know that these two things are congruent,
Oh wait, converse.
the converse of the base angles theorem. So because we already know that the base angles are congruent, it must mean that these are congruent to each other. Now in the picture we can see that we've got everything we want. Now we just need to prove it. We need to do it in a proof. So that's what we're going to do is we have proven everything there. We just need to actually write it out. Our statements and our reasons. Let's talk. What am I going to write? Okay. M is the midpoint of AB and, not A dot B, but AB. And the measure of angle 1 is congruent to the measure of angle 2. All of that was given. Gio, what did you do next? What did you do like at the beginning?
At the beginning?
Yeah, you kind of started us off.
Oh yeah, I said that AM is congruent to MB.
AM is congruent to MB. And what was your reason?
Yeah, definition.
Definition of midpoint. Okay. Midpoint. Then what did we do? Yes, ma'am?
Segment AC is congruent to segment MB.
Not MB. We couldn't do that yet. We didn't do that yet.
Oh wait, oh AM.
AM. And what was our reason?
Base angle converse.
Good. The converse of the base angles theorem.
And then
Isn't that all you need?
AC equals MB.
So
because,
AC.
differentiate.
Beautiful. So check it out. AC is congruent to AM, that's on this line, and AM is congruent to MB, that's on this line. So we join those two with the transitive property. Or substitution. Either way is fine. Trans sub. Honestly, those of you, I think some of you are really getting the hang of proofs. You really are. Now, they may still suck and they may still be hard, but you're getting the hang of them. I didn't say they were easy and I didn't say they were fun, but some of you are really getting the hang of them. So here's the things that need to happen today. Number 1, you need to finish your 4.8 homework. After that is done, you need to do your chapter 4 review, which we will be going over tomorrow. If you are done with all of those, then I'm going to have more stuff for you because I want you to make sure you are reviewed for this. There's no sitting around, no shooting games of pool. Everything we should be doing now should be focused on chapter 4. Capiche? All right.